Hi everyone, welcome back to my math channel online again. In this video, I will talk about the composite function in the course of pre-calculus Math 12. So what is the composite function? You can imagine like this. I have a function f of x, which is my left hand, and the function g of x is my right hand here. So let's say my function f of x will be opened, and I will put the function g of x into the function f of x. So basically, f of x is the outer function and g of x is the inner function. And the composite of it, which is f of g of x, we call a composite function f of g of x. So that is how I demonstrated. Now, let's look at in mathematics how we make a notation of that. So composite functions denote, I'm going to put here, denotes as f, the little o here stands for of. So f of g of x. Also, sometimes you see the way they write, they will say f, open the bracket, of g, open the bracket of x, and that's the same like this notation. So f of g of x. Now, if we reverse, let's say if we reverse, we will put the g of x outside as an outer function. So we will write g of a little o here of f of x. And the same as you write g outside of bracket, f of x, close the bracket. So either way, you can write both of way, either way denotes as a composite function. So let me demonstrate more obvious for you. Let's say if I have a f of x function is the square and g of x is the triangle. So basically f of g of x will be fx is the outer function and g of x is the inner function. So the triangle will go inside the square. So that is the idea about the composite function. So let's find out in the example 1 here. Given to you f of x equal to x plus 1 and g of x equal minus 5. Find the f of g of x. So how are we going to deal with this? So what you can identify is f of x is the outer function and g of x is the inner function. So basically, if f of x is the outer function, we follow whatever the expression of f of x here. But the x in here, let's say f of x here equal 2x plus 1. So f of g of x will be equal to, and instead of x now, this x you will replace by the g of x. So g of x here is minus 5. So it means 2 minus 5. We substitute for the x and plus 1. So 2 times minus 5 is minus 10. Minus 10 plus 1 is minus 9. So this is the result of a function f of g of x. Now, what about, now in this case, we only can define the function f of g of x. We cannot define the g of f of x. So in here, just one of example for you to see f of g of x. I also want to explain a little bit further for you to understand in terms of domain and the range, right? Let's say if I have an f of x function equal 3x plus 3x minus 2. Let's say I have a function like that, right? Now, this is the linear function. So the domain of this is on x belong to the real number. So we not restrict anything. X can be any number because this is a linear function. So if you draw it on the graph, 3x minus 2 could be something like that, right? And you know that the arrow go both ways. So this, it doesn't restrict any domain. So the domain of the linear function is belong to the real number from negative infinity to positive infinity, include rational number, irrational number, everything. So we cannot belong to the real number. So that is the domain of this f of x. Now, when asking about the range, how do we define the range? Now, the range of this function is the y value, right? The y value of this function. And of course, if it is a linear, the range of this function is on the way from negative infinity to positive infinity as well. And whatever outcome, if we substitute x by any value, right? If let's say if x equal 1, we substitute by 1. If x equal 2, we substitute by 2. And we calculate the range, the coordinate y, right? The range is a set of y value, right? So we calculate the range based on the domain of x. So whatever the x here, we substitute in here, the result here will be the range of this function. So if we're talking about the composite function, then you realize that if I write, let's say if I write the function f of g of x. So basically, g of x here is the range. Because g of x could be equal minus 5. So minus 5 here is the range of g of x. And therefore, when we have a composite function f of g of x, it turns out the range of g of x, right? This is the range, is the domain of f of x. So the range of g of x is the domain of f of x. So the range of inner function is actually the domain of the outer function. So that is the one more point I want to mention to you about that, right? So the range of g of x is the domain of f of x. So keep in mind all of this to understand about the composite function. And because of this condition, so sometimes the function f of x is restricted by the domain of g of x or by the range of g of x. So the domain of f of x is restricted by the domain of g of x. So basically, the range of f of x is restricted by the domain of g of x. Maybe it sounds a little bit abstract to you, but it's not that bad if we calculate, if we evaluate it. So let's take a look at this example. You will be able to understand about the domain and the range between the composite function we are talking about. So let's take a look at the example here on the board here I wrote. So given to you a function f of x, and this time the function given in the coordinate, right? Coordinate form. So you have a function f of x with a set of coordinate like this: 2, 6, 4, minus 1, 1, 3, minus 2, minus 5, so on. And the g of x with the set of coordinate like this. And recall that the coordinate always go x and y, right? Never reverse y and x. Okay, so x first and then y. Now, x is the domain, right? A set of domain, and y is a range, basically. So now, question 2a asks us find f of g of x. And the question asks if it is acid. And sometimes the composite function acid, and sometimes they're not acid. And the reason, because we just talk about the restriction of the domain of g of x, the range of g of x restrict the domain of f of x. And that's why sometimes, let's say if your outer function is too small and your inner function is too big. Let make example like that. Maybe you understand better, right? So let's say you have a function f of x is so small like this, and you have a big function g of x, and you want to ask like, what is the f of g of x? How you're going to put a big function here inside the small function like that, right? It doesn't happen that way because this is too big and you cannot put it in. But if the function outer is bigger, it can cover the range of this function, and it become a domain of this function. Then yes, you can put it in, and that become a composite function. So maybe I make that demonstration for you to see it not so abstracted, right? Okay, so let's take a look at here. Find f of g of x. So first of all, the question like this, we know that the f is the outer function. So f is the outer and g is the inner function, right? So we want to find f of g of x. We know that f of g of x, and let's put this way, so you know this g of x here is actually the range, right? The range of g of x is become a domain of f of x. So basically that's the idea, right? Okay, so first, let's identify the range of g of x first, right? Because we want to find the range of g of x. So the function g of x will have a range look like this. G of 4, right? G of 4 is the domain because that's a set of x value of g function, right? So the x here stands for the 4 here. So you know 4 here is the domain, right? So g of 4 equal 2 because this is the y coordinate, right? So the y, this is the y, right? So y equal 2. So you can see that this is the g of 4 is the y of coordinate. When what is the y when x equal 4, right? So when x equal 4, which is domain of g of 4, equal 2, and 2 is the y coordinate of g, which is the range of g, right? So now we know g of 4 here, which is y equal 2 here. So g of 4 equal 2. Let's write down another set. G of minus 5 equal 4. G of 0, which is here, equal 1, right? Based on this coordinate. And the last one, G of -3 equal -2. So the number inside the bracket here is the domain of G. But the number outside the bracket, which is the second coordinate, which is the y coordinate, is the range of G. So basically, if the question asks you to find f of G of x, you have to find f of the range of G of x, right? So it means if you put f of G of x in here, you will substitute this as f of G of 4, right? You will substitute like that. G of x, which is f of G of 4. But what is f of G of 4? F of G of 4, now G of 4 equal 2. So it means you can substitute f of 2 because G of 4 equal 2. So you substitute G of 4 equal 2 in for f of x, f of G of x. So now you will look at f of 2, you look back in here, f of 2 equal 6, right? That's the answer. So the answer is here. Now let's do another one. F of G of -5. And it means f of G of -5 is 4. It means f of 4. So f of 4 equal -1. So that's second answer, right? Now we're gonna find f of G of 0 and G of 0 equal 1. So it's the same like you talk about f of 1. And f of 1 is equal 3 based on this coordinate. The domain of 1 equal 3. So now the next one, so we deal with G of 0, now we do G of -3. So f of G of -3 is -2. So let's put here f of -2. F of -2 equal -5. So all of this value are existence. So you can't, yes, if the question asks you if it exists, you will say, yes, it exists, because we find all the value, right? F of G -5 equal f of 4 equal -1. F of -2 equal -5. F of 2 equal 6. F of G of 0 equal f of 1 equal 3. So they all exist. So that is how we answer the first question. So now I hope that you can follow me, right? Sometimes it's a little bit complex if we have to look on the number, right? So sometimes, but I hope you can follow it. Now find G of f of x. Now in the second question, it reversed. It asks us to find G is the outer function and f of x is the inner function. And again, it's question if it exists. So let's check, right? Let's check to see if it exists. So now we follow that G is the outer function, right? So let's find the range of f of x first, right? This is the range, right? The range of f of x. So let's list all of that first. So the range of f of x, which is f of 2, right? Let's list that. F of 2 equals 6. What else? F of 4 equal -1. And f of 1 equal 3. And f of -2 equal 5. So now we focus on this value, right? We substitute in. We focus on the range of it. So now we will find g of f of x. And remember, f of x here is just the y value, right, of the f function. And the y value of 2 equals 6. So here we have g of f of x. We substitute f of x by the range is 6. And we look at the g function here, coordinate here, g of 6. We don't have any domain of 6 in here. See 4, see minus 5, 0, minus 3. So we don't have it. So we say empty set. We don't have it, right? We cannot find the g of 6. Now let's try another one. G of minus 1. Let's look at our function. We have 4 here as the x domain, minus 5, 0, minus 3. Again, we don't have g of minus 1. So it's the empty set again. We don't have it. Now let's do g of 3, right? G of 3. And g of 3, we have minus 3, but we don't have 3. So again, this is an empty set. What else do we have to find? G of 5, right? G of f of minus 2. F of minus 2 is minus 5. Sorry, it's my mistake. So this is minus 5, right? So now if we put in g of minus 5, do we have it? G of minus 5, yes, we have it. G of minus 5 equal 4. So the only value we can find here is the, so we can say that the only domain of f, right? Only the domain of f of minus 2, right? Of minus 2 can put in the composite function, right? Can be as it for a composite function of, for g of f of x. So that's our conclusion, right? It's a little bit jam here, so I'm going to write here. For the second question, now you can see it different, right? For the first question, all of the value are as it. But for the second question, we say only f of minus 2 can be the domain for both f of g of x, right? So this is the domain for f, but also can be the domain for f of g of x as well, because where we can find the y value of the composite function f of g of x. So this is basically what I tried to explain to you about the composite function. So I found it interesting, right? But I hope you follow me. So let me summarize a little bit for you, right? So we're talking about the composite function. It means we have an outer function and we have an inner function, and we put in the outer function. And we make sure that the domain of the inner function, right? The range of the inner function have to be smaller than it have to be smaller than the domain of the outer function, right? So that you can put it in. Now, so basically, if the domain of the inner function is too large, and the domain of the outer function were restricted, right? Were restricted by a small number, then some of the domain of the inner function will be out of the range. You cannot put it in, and you cannot have a composite function as it. Basically, that is the idea, right? So I demonstrated here for you to see that the side of the big square here, right? Let's say f of x is a big square and the g of x is a triangle, and you want to find f of g of x, then the side of this has to be smaller than this in order you can put in. If you draw a big triangle like that and you want to put it in here, then there's no way, right? It's too big. You cannot put in, become an inner of this. But if you reverse, you say g of f of x, then yes, it's okay. You can put the square in the big triangle. So basically, that is very concrete after I explain like that, right? Okay. So we went through how to find the f of g of x, given the function f of x equal to x plus 1 and g of x equal minus 5. So all what we do is we follow the format of the outer function, and we substitute the x here, whatever the x here, we substitute by the value of g of x. So 2 times minus 5 plus 1 equal minus 9. So that is how we calculate it. Now, for the set of coordinates, it's a little bit complex. However, if you do one by one, you do step by step, you list on the range of the domain of g, right? You say g of 4 equal 2, g of minus 5 equal 4, g of 0 equal 1, and g of minus 3 equal minus 2. You follow that, right? Then you say f of g of x, it means f of g of 4. But what is g of 4? G of 4 equal 2. So we can substitute the whole thing here, g of 4 here, become 2, right? This bracket, the whole thing here, g of 4 equal 2. You substitute f of 2. And f of 2, so now 2 become the domain of function f, right? So 2 here represent the set of x value. So you look at the function f of 2, because x is 2, so you look at x is 2, then the range of it is 6. So f of 2 equals 6 right here. Follow this coordinate, right? And then f of minus 2, then you look at f minus 2, you look at the f function here, right? F minus 2 equal minus 5. So basically, that about it. So I hope you enjoy this video as well. And thanks for watching. So I'm going to end the video of composite function right now. And I hope that you follow me well and you understood about this. And to all my students across the world, please, if you like the way I explain, please follow my register to my math courses. Math courses hyphen, that's, let me remind to you, math courses, so https plus math courses hyphen online.teachable.com. You can register to my courses. I am going to make the PowerPoint presentation. For each unit, you will have a beautiful PowerPoint presentation for each lesson, and layout connected, well connected together. You have on the sample solution as well as the answer key and practice exercise. So if you just watch me on the board, that's fine. You can follow me on YouTube, and please hit subscribe and like if you like my work. And actually it's a hard work. So thank you for watching, and bye for now.